Hi, today we'll be talking about axonal transport or exoplasmic flow or exoplasmic transportation, in short AXT. This is a non-impulse based conduction through the core of the fiber, a flow through the core of the fiber of proteins, both from the central system towards the terminals of the axons. This is antegrade flow, and from the terminals back to the central system, which is retrograde flow. It transports a number of different structures, including brain growth substances, axonal growth, nerve growth substances, enzymes for regeneration and repair of nerve fibers, metabolites coming back on the retrograde flow, and so on. More important for us, though, is that it transports through the antegrade flow rapidly synaptic vesicles to replace those that have been lost during a synaptic exchange of nerve conduction. And also trophic factors to the end organs that maintains trophic nutrition to these organs, ligaments, muscles, bone, tendons, fascia, and so on. The process is actually produced not by pressure as such from one end or the other, but from kinetic proteins. These move the substances up and down the nerve fiber, and so there's no pressure build up in the nerve fiber as such. It's not like water being pushed down. These kinetic proteins travel in microtubules and carry, which is called a cargo, carry these substances up and down the axon. So don't think of this as a pressure forcing this stuff up and down. The loss of this flow, the compromise of this flow, can result in a number of things, including degeneration effects in the axon. Central nervous system defects is thought to be partly, at least, responsible for Alzheimer's, Parkinson's, Murray-tooth disease, and so on. So it's vital to the health of the nervous system. For our purposes, though, it's the two functions it has in maintaining synaptic exchange and also trophically nourishing the end organs. Now, without these factors, you'll get fatigable weakness. And this is detectable during the physical exam. So you'll find this weakness, and it'll be distributed according to what's blocked. So if the flow is blocked at the spinal nerve or nerve root, you'll find that weakness distributed in a segmental pattern. If it's occurring in a nerve, then it may turn out to be a total neuropathy. I mean, total in the fact that the distribution may be total, or it may be an end part of that nerve. So the distribution is variable. Also, this flow is more susceptible to disruption than is the electrical flow, quite a lot more susceptible to disruption. So don't expect to find other factors that you might find with a radiculopathy or neuropathy, such as sensory loss, reflex changes, or even Tinel's test. This sensitivity to compression, traction, torsion, shear, and so on means that you can have quite minor factors causing this disruption. And this can evidence itself as a multi-crest syndrome. So you'll get a block, say, at the spinal nerve root, which isn't by itself enough to cause clinical changes. But another block, say, at the elbow, may produce changes from the elbow downwards. So these multi-crest syndromes will be seen distal to the distal block. Okay, in a nutshell, that's it. I'm going to put a mind map up, and we can discuss this in more detail on that mind map. This mind map shows the basically the significant functions of AXT to us as manual therapists, while the lower part of the mind map talks about identifying it and separating it out from the other causes of weakness. So if we look at the top part first, there's two flows, antegrade and retrograde, and they come in fast and slow modes. First one we look at is fast antegrade transmission, that is from the central system out to the terminal finals. The one we're interested in are the neurotransmitter substances, which replace the vesicles at the synapse that are lost as a impulse jumps across them. Not all of it is resorbed. This replaces that which isn't resorbed. Generally speaking, it's only the motor losses that is gone, because this puts the biggest demand on the synapse and it uses up the vesicles faster than sensation or reflex testing does. So you're not likely to find anything other than motor loss. The motor loss, though, will be fatigable, as it is with most of our neurological problems we come across. So you'll find fatigable weakness without any other neurological signs associated with it. The other antegrade flow for us is a slow flow, and this is trophic nutrient transport to the end organs. So the ligaments, tendons, muscles, bones, joint capsules and so on all rely on this for trophic nutrition, and when this is denied them, they degenerate. So this will be a potential factor when we're looking at etiologies. Now, we can identify fast flow loss because of the fatigable weakness and no other neurological signs, but the slow flow loss has to be assumed to be present when we identify the fast flow. You can't identify that independently. Now, just to get this out of the way, this is not neurophysiological, this is neurological. It's a radiculopathy or a neuropathy, the same as electrical conduction is, except it's only affecting the flow through the axon. But make no mistakes, this is a radiculopathy or a neuropathy. The map below it looks at identifying it, and we'll look at fatigable weakness because this is the weakness that is associated with axonal loss. So we then look at the distribution. It's either going to be segmental or radicular, or it's going to be peripheral, or possibly plexopathic, but less likely to be that one. Do you find any other neuroscience? If the answer to that is yes, and wobbling is no help, you're looking at a radiculopathy. A straightforward hard radiculopathy. If there are no other neurological signs and the wobble doesn't help, then the only thing you can assume is that it's an AXT compromise, and then you find the choke points and try and deal with them. If the weakness is braking weakness, the distribution should be local, which would mean it's reflex inhibition. Wobbling will help, and then you can do a more formal testing by looking at end range, eccentric contractions, looking for that braking weakness. If this is non-fatigable, non-braking, and then the distribution is segmental, wobbling does help, then it's probably segmental facilitation, in which case you see changes in tone, and the other change you'll see is scratch reflex loss and orange peel skin and so on.